Okay, this is the M1 paper from January 2023. It's question number 5, and as you see, as I scroll up and down it, it's a kinematics question, but there's a lot of detailed information on here, so I suggest you pause the video and have a read through of it all rather than me taking ages to read through the thing, and then we'll be able to make a start on it. Okay, I'm assuming you've done that, so yeah, it's a vehicle of some sort that starts off at P, passes through Q. When it gets to Q, it decelerates, but that's going to be for part B. So I'm just going to concentrate on part A here. So for part A, the motion is from P to Q. So let's just do a quick diagram from P to Q. What do we know? Well, we know that it starts off with a speed of U. We know that it finishes with a speed of 2U. We know that that time there is t equal to 12 seconds. And I think that's it so far for what we know. Yeah, so it asks us to show that x is equal to 3u. X is obviously going to be the distance that it's travelling here. We know that that's 6x there. Sorry, yeah, that's the other piece of information we know. So if I'm looking at this is a classic SUVAT question. Let's just set up our SUVAT S, U, V, A, and T here. So what do we have from this initial piece of information? We know it travels a distance of 6x. We know it starts off with the speed U. We know it finishes or goes past there with the speed of 2U. And we know it takes 12 seconds to do that. So how do I connect these four? Using SUVAT S, U, V, and T, that's going to be, got 5 choices of formulae. I'm going to use S equals U plus V over 2 times T. So if we sub that in then, we get 6x is equal to 2U plus U over 2 multiplied by 12. So that's going to give us 12x. Is 2u, or rather is 3u times 12 is 36u, so that's going to give me x equals 3u, which is what we were asked to show from the first part. Okay, second part, it then says, as the particle passes through Q, acceleration changes instantaneously. I won't make a comment about how it does that, but to 1.5 meters per second squared. Continues to move with the acceleration and passes through R, this time with a speed of 3u. Can we find out what u is? So let's say that our diagram now is from Q to R this time. Okay, starting off at Q and ending at R. We know that this speed is 2u. We know that this speed is 3u. We know that the acceleration at this time is equal to 1.5 meters per second squared. We know that it's going to go a distance of 5x there. So now let's put all that information into my SUVAT again. So S, U, V, A, and T. What have I got this time? Well, I've got that S is going to be equal to 5x, and I know 5x, then 5 lots of 3. 5 lots of 3u is 15u there. I know that it starts off with 2u, it ends up with 3u. I know the acceleration is equal to 1.5, and we're interested in t there. So what formula this time connects S, U, V, and A? Obviously, that's one of the other formulae. V squared equals U squared plus 2AS. So if I put that in, I'm going to get an equation, a quadratic in terms of u on it. So let's see what we get. We're going to get 3u squared is equal to 2u squared plus 2 lots of 1.5 lots of this 15u here. So let's tidy that all up. That's 9u squared, that's 4u squared, and that's 45u. So I'm going to get 5u squared. If I put it as a quadratic, minus 45u is equal to 0, which gives me 5u out, u minus 9 equals 0. So I either get u equals 0, which can't be a possibility, or u equals 9 meters per second. Obviously, u can't be equal to 0. Nothing would be happening. So yeah, that's part B done as well. Find, using the model, find the value of u. And then part C says, find the distance travelled by the vehicle during the first 14 seconds after passing P. So let's just go back to this diagram and remember, it does 12 seconds there, so it will do a further 2 seconds in the journey from Q on the way to R, but it won't quite get there. So from P to Q, so let's work out, let's do part C, sorry. So part C, from P to Q first of all. So from P to Q, it's just 6x. S is equal to 6x, which was 18u, which is now 18 lots of 9. So that's whatever that works out to be, 162 meters. And then from Q onwards, or after Q, what have we then got? Well, we've then got to use SUVAT to be able to work that out. So we know that, going back to this information here for this information, we know that U is equal to 9, remember? So I'm going to have U is 18, I'm going to have V, I don't know, that's what I'm trying to work out. A is 1.5, let's put all the information in. So do a SUVAT again, here, after Q, maybe here, put 2 seconds on there when we're looking at it. So S, that's what I'm looking for, don't know what that is. U is going to be equal to, U is going to be equal to 2U, okay, if that makes sense to you. Our initial speed, the speed at Q is equal to 2U, so 2U is 18. V, don't care, I'm not interested in that at the moment. The acceleration is equal to 1.5, remember, in that part of the journey, and we are only doing 2 seconds worth of that journey through. So S, U, A, and T, well, that's the third one of our kinematics formulae. S, U, A, and T, I'm going to use S equals UT plus half AT squared. So S will be equal to 18 times 2, half lots of 1.5 times 2 squared, and then just work all that out. Works out to be 39 meters. So the total distance travelled is 162, whoops, handwriting, 162 plus 39, which works out to be 201 meters. Okay, yeah, so quite a long kinematics question there, setting up some equations to be able to solve that, but hopefully that all makes sense to you if you check it through a couple of times.